All right, greetings everyone. This is the second part of the video for section 2.5. So we will continue on with our study of more stuff about absolute values. Okay, so question I want us to think about. How many horizontal intercepts can an absolute value function have? So I've been thinking about these during chapter 2. How many could an absolute value function have? And assuming that maybe it's been transformed somehow, what could it be? Well, let's look at three different possibilities here. So in the first first graph over here on the left, notice how many horizontal intercepts are there. And remember, horizontal intercepts means where it intersects the horizontal axis. In this case, it looks like there would be 0, right? Because if we look at the horizontal axis being this one here, that absolute value function there will never intersect it. So there's an example where we could have 0. The second one, notice, intersects the horizontal axis in one spot, right there at the origin. So it looks like we could have 1. Or in the case of the example we started this section with, notice that it has 2, right? It intersects there and there. So 3 different possibilities for the number of horizontal intercepts that an absolute value function could have. It could have 0 if it opens up or down and it doesn't cross the horizontal axis. It could have 1 if it just hits it in one place there at its vertex, at its point. Or it could be 2 if it's been flipped over and shifted up like this one has, or maybe just taking like this original one here and shifting it down, you would get 2 horizontal intercepts, right? Okay. Let's talk about finding those with absolute value functions. So here we have to determine if each of these has 0, 1, or 2 horizontal intercepts, and then also find them. And recall, we've talked about earlier in this chapter that a horizontal intercept for a function, regardless of what the function looks like, so it could be something like this, right? It's going to be a point where it intersects the horizontal axis, and the coordinates there will always be number, comma, 0, right? So the output values are always 0 at horizontal intercepts, okay? So based on that, what we need to do with each of these functions here to find the horizontal intercepts or to find the coordinates is to set them each equal to 0, right? So we'll take the first one here. We'll say 0 equals 5 times the absolute value of x minus 2 minus 3. Isolate the absolute value there, so add 3 to both sides. So end up with 3 equals 5 times the absolute value of x minus 2. Divide by 5 on both sides. So now we have absolute value of x minus 2 equals 3/5. Set up our 2 equations from there, right? So we should have x minus 2 equals 3/5, and x minus 2 equals negative 3/5. So we can add 2 to both sides. When we do that, we'll end up with x equals, and we're again going to have to do some fraction work here. Leave it up to you guys to double check my work here. So I think I get 13/5 in the first one and 3/5 in the second one. Is that right? Nope, the second one is wrong. This one should be 7/5. Right? Yeah, okay. And we're going to write these as coordinates. So recall again that horizontal intercepts always have the form number, comma, 0. So in this case, we'd have 13/5 0 and 7/5 0 would be our 2 coordinates of our horizontal. So that was one where we had 2 horizontal intercepts, right? Cool. Let's look at the next one. So the h of x equals negative 3 times absolute value of x minus 1 minus 9. We will go ahead and set that equal to 0 again, because we know the output value at a horizontal intercept is 0. So our equation will look like 0 equals -3 times the absolute value of x minus 1 minus 9. I isolate the absolute value here, so we'll add 9 to both sides. So we end up with 9, positive 9 equals -3 times the absolute value of x minus 1. Okay, divide by -3 on both sides. I isolate the absolute value. And when we do that, it looks like we end up with absolute value of x minus 1 equals -3. And notice here what we've gotten is the absolute value of something equals a negative number. Is that possible? No, it's not. So what does that tell us about the horizontal intercepts of this function, h? Right, they do not exist. So and this is going to be an example of where we have 0 horizontal intercepts. Okay, so that one doesn't have any. And let's look at the last one. So here, now I'm going to take that function g of x, which equals 1/2 the value of x plus 4. We'll set that equal to 0. So 0 equals 1/2 times the absolute value of x plus 4. Again, got to isolate the absolute value here, so we'll divide by 1/2 on both sides. And 0 divided by 1/2, we know that 0 divided by anything is 0. So if 0 equals absolute value of x plus 4. So now we have our absolute value function isolated. We could set up two equations, do x plus 4 equals 0, and x plus 4 equals -0. But what is -0 equal to? Right, that's still 0. So we'd actually end up with the same equation twice, which is going to give us the same answer each time. So we actually only need to set it up once. So if 0 equals x plus 4, and we subtract 4 from both sides to solve this, we'll end up with x equals -4, which again as a coordinate point would be -4, 0. Okay. So notice in this case, we ended up with just one horizontal intercept. Okay, so we saw examples of all the 3 different possibilities. All right, for the last thing for this video, notice that question there at the bottom. It says, how many vertical intercepts can an absolute value function have? So now we're talking about intersecting the vertical axis. How many could that be? Well, because of the shape of an absolute value function, right? Regardless of how we move it or transform it, it's always going to have to hit the horizontal or the vertical axis at least once. We can never make it hit it 0 times. Can we make it hit it more than 1 time? I think the answer is no, right? No matter how I moved this absolute value function here, looks like it's only ever going to hit that vertical axis there once. Okay, so at most, an absolute value function can only ever have one vertical intercept, and in fact, any function can only have one vertical intercept. All right, that's all for now. Thank you for watching.